A chiral carbon is a carbon atom that is also known as a stereocenter or an asymmetric carbon. It is actually bonded to four different substituents, which just means it's bonded to four different groups. Because the carbon is bonded to four different groups, the carbon cannot be symmetrically superposed on its mirror image. It becomes chiral. And I'll go ahead and teach you how to properly identify a chiral carbon, also known as a chiral center. A hack I like to use is first looking for a dash and a wedge. If you're not yet comfortable with reading this type of molecules, then it's best to draw those invisible hydrogens so you don't make a mistake. Remember, carbon is always bonded to four different things, so you're always gonna have four different bonds. In this case, you saw how this is bonded, this carbon has two bonds here, one, two. So it has two hydrogen that it's bonded to. So because this carbon particularly is bonded to one hydrogen and another one, those are the same. Those are not different. So that is not a chiral carbon. Remember what I said a while ago? A dash and a wedge. It's great to look for chiral centers there. Usually, but not always. So we have here one different group of hydrogen, two, three, four different groups. So that is a chiral center. Over here, once again, let's look at the chiral center. In this second molecule, looking at the dash and the wedge, four different groups that it's bonded to. If you have to draw the H's, the hydrogens, it's completely fine. It's better to draw them than to make a mistake. So one, two, three. In this, I'm looking here at this carbon. If I just said a while ago there are four different bonds, and there's three here, it's missing one more. So there's an invisible hydrogen right there. This is H3, H3. So looking over here, is this a chiral carbon? It's bonded to here. It's bonded to hydrogen, but it's bonded to two methyls. Nope, it's not. The rest aren't either. Look at them, they're bonded to two hydrogens. This is bonded to three. So of course not. They need to be bonded to four different groups. So in this case, looking at our dash and our wedge, we have four different groups. So we found our chiral center, our chiral carbon. Over here, our third molecule, we have here our dash and our wedge. There's one different group, two, three, four. So because of that, we have our chiral carbon. How about over here? I'm looking at four bonds. This be chiral center. Let's go ahead and draw our invisible H's. This a methyl, this a methyl. Now that we see that, it's actually not a chiral center because this is methyl. They're the same. So nope, it's not a chiral carbon. The rest aren't because they have those invisible H's. Now, looking at the next one, how about from what we've learned, looking at the dash and wedge, you usually find a chiral carbon. But this would be a chiral carbon. One different group, second different group. But are these different? No. And because of that, it's actually not a chiral center. So this does not have a chiral center. And there you go.